So light. Radiation means light. So now we know that light is a wave or light is a particle.
Light is a wave.
Light is a wave. Generally, we say light shows wave nature or light is a wave. But this is not true. Light sometimes behave as particle also. Okay? Light is
Yes,
a
sir.
wave, we know.
Yes,
But
sir.
light is a particle also, means light have dual nature. Means radiation have dual
nature.
nature. So why we say that light is a wave? Because we know light shows the reflection, refraction, diffraction, interference. So that is why
Yes,
we
sir.
say light shows the these phenomena, and these phenomena are related with the wave nature. So that is why
Yes, sir.
light have the wave nature. But at the same time, when we will study the photoelectric effect, so photoelectric effect proves the particle nature of light. Photoelectric effect can be explained with the help of the particle nature of the light.
Yes, sir.
Means light shows wave nature as well as the particle nature.
Particle nature.
Yeah. Wave nature as well as the particle nature. So the particle nature we will see in the photoelectric effect.
Yes, sir.
Photoelectric effect is given by Albert Einstein. Photoelectric effect. Actually, there are other scientists also. There is the contribution of many scientists on the photoelectric effect. Okay.
Yes, sir.
But the more contribution is of, I think, Albert Einstein. So that is why he had given the Nobel Prize on this photoelectric effect. Okay.
Sir, just a minute.
Yeah. You want to write it down?
No, sir, just a minute. The internet is fluctuating. Just a minute.
Okay.
Yes, you can continue.
Okay. So what you can say, radiation have dual nature.
Dual
Wave
nature.
and particle. Now
Particle
come to the
nature.
matter. What is matter? Anything which has
Like,
space and
yeah,
have mass.
mass and
Is
occupies
matter.
space.
So matter is a particle or matter? Like matter means you can say your pen and all these things, means laptop, mobile phones. You will consider these as particle or you will consider these as wave?
Particle.
So matter is a particle, we know.
Yes, sir.
Matter shows the particle nature, we know.
Yes, sir.
But in this chapter we will study that matter will also show wave nature. So matter also have dual nature. Okay. Matter will also have dual nature. So what is the name of the chapter? Dual nature of matter and radiation.
Yes, sir.
So I think now it's clear why the chapter name is matter, dual nature of radiation and matter, because radiation and matter have dual nature. So this thing is given by the experiment Davison and Gerver experiment. Davison and we should keep the class on the same time or for some other time?
So same time, sir.
At the same time. Okay. Germer experiment. So with the help of this experiment, they proved that electron shows diffraction. Diffraction of electron. Diffraction. Of electron, and diffraction is a property of wave.
Yes, sir.
So we can say that an electron is a particle, and electron is showing a wave nature, means particle is showing a wave nature, means matter is showing a wave nature. So matter have the wave particle nature as well as the wave nature. Radiation has the particle nature as well as the wave nature. So name of the chapter is dual nature of
dual nature matter.
Dual nature of matter and radiation. Radiation and matter. Radiation and matter. After this, we will discuss photoelectric effect. We will discuss photoelectric effect. Now see what is photoelectric. Very easy. Okay. These are the first of all, this is a metal surface. Okay, this is some metal surface, and these are the free electrons on the metal surface. We know that
Yes,
in
sir.
metals there are free electrons. Okay, in metals there are free electrons, because metals are the conductors of electricity. Okay,
Yes, sir.
metals are the conductors of electricity. That is why these means metals have the free electrons. So on the surface of the metal there are free electrons. These are the free electrons. Okay, these are the free electrons, and this is the radiation incident on the metal surface. This is the radiation incident on the metal surface, and this radiation of high frequency, this radiation have high frequency or low wavelength.
Yes, sir.
Radiation of high frequency and low wavelength. So in this phenomena, we will see in this phenomena we will see this light will be made up of photons. Okay, this radiation will be made up of photons.
Photons.
Yeah. So basically photon theory will explain the photoelectric effect, and photon is like a particle.
Yes, sir.
I'm not saying photon is a particle, is like a particle. So what is this? This is photon. So what is happening actually, we can explain with the help of photons this effect. Actually these photons are coming in the form of the radiation, means the radiation is having the photons. So these photons are colliding with these electrons, and these electrons are ejecting out. These electrons are ejecting out, and
ejecting out.
yeah, this phenomena is known as the photoelectric effect. Okay, these photons are coming, and these photons are colliding with the electrons, free electrons, and due to that free electrons are getting energy, and due to that energy the electrons are ejecting out from the metal surface.
Yes,
and
sir.
this phenomena is known as the photoelectric effect. Okay, so after this there are certain things that we will discuss. Light consists of wave packets called photons.
Photons.
Basically this is light. This light is made up of photons, or you can say wave packets, or sometimes we say energy packets or quanta also. Different names, but you should say light is made up of photons.
Photons.
And these photons are striking on the metal surface and colliding with the electrons. Due to that the electrons are gaining energy, and due to that energy electrons are ejecting out. This phenomena is known as the photoelectric effect. Okay, after that, very important point, the mass of the photon is not defined.
Yes, sir.
For example, the mass of some the mass of the mobile phone will be there, like 100 grams, like 500 grams. Okay, there is mass, defined mass, but for photon the mass of the photon is not defined in sense of the Newtonian mechanics. Newtonian mechanics means classical mechanics is there, the mechanics that is given by the Newton. Okay, so with respect to the Newtonian, because mass is a concept that is with respect to the Newtonian mechanics. Okay, mass is a concept with respect to the Newtonian mechanics. Yeah, so we calculate mass by applying the Newtonian mechanics. With respect to the Newtonian mechanics, the mass of the photon is not defined. but the rest mass of the photon is 0. Means when these photons suppose will be at rest, right now these photons are moving like this. If these photons will be at rest, then rest mass that, and at that condition the mass of the photon will be considered as 0. Next point, all photons travel with 3 into 10 to the power 8 meter per second in air and vacuum. What is 3 into 10 to the power 8 meter per second? This is the speed
Velocity
of
of
light.
the
Speed of electromagnetic wave, or you can say is light is an electromagnetic wave.
yes,
So
yes.
all
Speed of
photons,
light.
all photons travel with the speed of light in air or vacuum. And photons are neutral in nature. So neutral
sir.
means photons do not have any type of
Any
charge,
charge.
positive or negative. Okay. Another point, each photon have definite energy and definite momentum. These photons
Yes.
these photons do not have, means we cannot define the mass of the photon. Okay, but
Okay.
the photon have the momentum and energy, and energy of the photon is very important concept. We will use energy of photon again and again and again and again to define. Okay, so energy of photon energy of, do you know what is the formula for energy of photon?
Yes.
E is equal to HF.
HF,
E is
yes.
equal to H into frequency of the incident radiation. Okay, suppose these are the radiation. Okay, and this radiation is made up of what? Photon.
Photons.
So suppose this is photon. So we are calculating energy of this photon. Energy of this photon is given by H into frequency, and this is also given by H into C divided by lambda. Now what is frequency? Frequency is frequency of the radiation, because this is radiation. Understanding now?
Yes, sir. Yes.
This radiation have some frequency, and energy of photon is given by Planck's, H is known as the Planck's constant. H is known as the Planck's constant. The value of Planck's constant H is given by 6.626 into 10 to the power minus 34 joule second. F is the frequency of radiation, incident radiation. Okay, frequency of radiation. Lambda is the frequency, not the frequency, wavelength of radiation. Lambda is the wavelength of radiation. Lambda is the wavelength.
Wavelength of radiation.
So energy of photon is HF or HC by lambda. HF or HC by lambda. Now momentum of photon. Momentum of photon. Do you know what is momentum?
Yes, like.
Tell me what is momentum. Formula for momentum.
Formula, sir, I forgot for formula.
Momentum is basically mass into velocity.
Mass into velocity, MV, right?
MV. So momentum of photon is represented by P. Momentum is represented by V. Because here na mass of the photon is not defined. So momentum of photon is not MV. Momentum of photon will be H by lambda. For any other mass, and that mass m, and this mass is moving with some velocity. For this mass, the momentum will be mv. But in case of photons, the momentum will be different, h by lambda. H is the Planck's constant. Lambda
Yes,
is the
sir.
wavelength of the incident radiation. After this, all collisions, this point is important, all collisions between photons and the matter particles like electrons are perfectly elastic. What I told you earlier, you can see here. I told you these photons are colliding with electrons. These photons are colliding with electrons, and the collisions are perfectly elastic, means during the collision or before and after the collision, the momentum will remain conserved. The momentum will remain
Will
conserved
remain
and the
conserved.
kinetic energy will remain conserved. Elastic
Conserved.
collision. So you can say that initial momentum and the final momentum will remain same, and initial kinetic energy and final kinetic energy of the system will remain same. After this point is there. On increasing the intensity of radiation, see, concentrate, this point is very important to
Yes,
understand.
sir.
On increasing the intensity of radiation,
The number of photons increase.
yeah, the number of photon increases, but energy of each photons does
Does
not
not
change.
change. Yeah.
I will explain this with the help of one example. Suppose we have two bulbs. One is of 50 watt and both bulbs are yellow bulbs. Both bulbs are yellow bulbs. Okay. And one bulb is of 50 watt, another bulb is of 100 watt. 100 watt. So if both bulbs are of 50 watt, so it means that if both bulbs are yellow bulb, so yellow means wavelength same.
Yes, sir.
For both the bulbs, wavelength of both the bulb will be same. And we know that the energy of photon will depend upon the hc by lambda, because h is the Planck's constant, c is also constant. So energy of photons is depending upon lambda. So you can say lambda is same for both the bulb. So you can say that energy of photon will remain same. Energy will not change.
Yes, sir.
Energy will not change. Okay. Now this 50 watt bulb and 100 watt bulb, the intensity of 100 watt bulb will be more as compared to the 50 watt bulb. So if you will talk about the intensity, so this bulb will
Because
have
more energy.
more intensity,
Yeah.
and this bulb will have less intensity. Okay, so if you are using 50 watt bulb, so it will have less intensity. If you are using 100 watt, suppose initially you were using 50 watt bulb. So if initially if you are using 50 watt bulb, means the intensity is less. Finally you are using 100 watt bulb, means you have increased the intensity. What will happen
Yes.
in this case? Number of photons will increase. Suppose here there are 10 photons. Okay, here are 10 photons. So in case of the 100 watt bulb, there will be 20 photons. Number of photons will increase.
Yes, sir.
But energy of each photon will remain same. Here will be less photons, and here will be more photons. Okay. Until and unless you are not changing the wavelength, energy of photon will remain same. Until and unless you are not changing the wavelength, the energy of photon will remain same. Yeah. So what will happen on increasing the intensity of radiation? The number of photon increases, but energy of each photon does not change. Remember all these points and remember the photoelectric effect. And now you can write down.
Done, sir. Second scroll down. Second, scroll down. Done, sir. Done, sir.
Okay. So remember this point. On increasing the intensity of radiation of light, the number of photon increases, but energy of each photon does not change.
Yes, sir.
Energy of photon will only change. Energy of photon will only change when you will change the wavelength, or what is the energy of photon? E is equal to h into frequency. Energy of photon is equal to h into frequency, or hc by lambda.
By lambda.
When you are changing the frequency or you are changing the wavelength, then only the
The
energy of
energy.
the photon will change, because h is constant and c is also constant. C is the speed of light. After this, we will discuss the work function. Okay. So what is the meaning of the work function?
Work function lambda. Phi.
Yeah, phi. Very good. Actually, now work function is very simple thing.
Yeah, it
You know,
came
do you
from
know what is
photoelectric
ionization?
effect, right? It came from photoelectric, like E electron plus A photon.
Yeah.
Electron is phi. That's work function.
Yeah. Means work function is known as phi. What is the work function? Is basically it is like just ionization energy. Do you know what is ionization energy of any element? The amount of energy given to that element to remove one electron from outermost shell. Means to remove electron, the amount of energy you are giving is ionization energy, na?
Yes, sir.
Yeah. Ionization energy means to remove electron, the amount of energy given, minimum amount of energy you are giving to that element to
Remove the
remove one
element.
electron is known as the ionization energy. Something like that now in chemistry. Okay.
Yes, sir.
Now here also what is happening? Electrons are removing from the metal surface. Electrons are getting removed from the metal surface.
Yes, sir.
Actually, what is happening? Photons are coming, and photons. What is the meaning of photon? Photon means energy is coming. Photons have energy.
Yes, sir.
Means energy is striking on the surface. Energy is striking on the surface. Due to that, in this way also we can say energy is striking on the surface. Due to that, electrons are ejecting out. Electrons are getting removed from the surface. Now, if I am saying that how much energy is needed? How much energy is needed to remove one electron from the surface? To remove the electrons from the surface, there is a minimum requirement of energy. It is
Yes,
not
sir.
like that you will give 1 joule of energy and the electron will remove. It is not like this, na?
Yes, sir.
Some minimum or a specific amount of energy you will give, then only the electron will be removed. And the minimum amount of energy given to the metal surface to remove one electron is known as the work function. Work function
Yes,
means the minimum. Suppose the work function of this metal is 2 electron volt. 2 electron volt is the work function of this metal surface. Means at least 2 electron volt energy you will give to this metal surface, then only the electron will be ejected out. Okay.
Yes, sir.
So very easy. Work function, same diagram. Okay, electrons are ejected. And one more thing I want to tell you, these ejected electrons are known as the photoelectrons. These ejected electrons are known as the photoelectrons. So radiation of high frequency and all that. Okay, if you want to just draw this diagram, then you can draw, and it is better to draw the diagram. For example, work function, we are saying work function. So work function is the minimum amount of energy required to eject an electron from the metal surface. Work function. For example, the work function of this metal surface, and work function is represented by phi. So suppose the work function of this metal surface is 2 electron volt. Of this metal surface is 2 electron volt, and you are giving the energy as 1 electron volt. Will the ejection of electron will takes place? Will the photoelectric effect will takes place? Means
yes, sir.
I'm saying that 2 electron volt is a work function of this metal surface.
Yes, sir. Yes.
And you are giving the energy
one
of 1
electron
electron volt.
Yeah.
Will the ejection of electron will takes place?
No.
No. Okay.
The energy should be more.
Yeah, energy should be more or either equal to.
Yeah,
if I am giving 1.5 electron volt, then also
no.
there will be no ejection of electrons.
It should be 2 or more than 2.
Yeah, it should be 2 or more than 2. Suppose I am giving 2 electron volt. So if I am giving 2 electron volt, there can be the ejection of electron. And suppose if I am giving 2.5 electron volt, if I am giving 2.5 electron volt, then there can be the ejection of electron. Why I am saying again and again there can be? Because what will happen? Suppose you have given the work function of this metal surface is 2 electron volt, and you are giving 2.5 electron volt. It is possible that if you are giving energy more than that of work function, it is possible that electron may not come out. Electron may not eject out. Why? See, suppose work function is 2 electron volt, and you are giving energy to this electron. Means you are providing energy to 2.5 electron volt. So what will happen? There are the neighboring electrons also. Electrons also. So suppose during the ejection out, when this electron is ejected from the surface, suppose this electron is collided with the neighboring electron, and due to that collision, this electron lost some energy. This electron can lost some energy in collision with the other electron, then this electron will not come out. Suppose 2 electron volt is expended to overcome the work function. Suppose this is the electron. To this electron, you are giving 2.5 electron volt energy. 2 electron volt is the work function. So 2 electron volt will be expended to overcome the work function. Now, what is the remaining energy? 0.5 volt.
0.5.
Now this electron will eject out and it will have a 0.5 volt energy. Now, suppose the electron, when ejecting out, at the time of ejecting out, it is collided with this electron. Now, during the collision, there will be the loss of energy. Suppose 0.5 volt is lost during collision. So will the electron come out? Now, no, because this time the electron will have zero energy. Electron will not come out. So it is possible that if you are giving an energy which is greater than the work function of the metal, so electron may come out, may not come out. But if there will be no collision, then you can say that the electron will come out definitely. Okay. Now we are taking the case when there is no collision. So suppose this is the electron, and you are giving this much energy to the electron, 2.5 electron volt. Now this electron will spend 2 electron volt to overcome the work function, and what is the energy left with the electron? 0.5 volt. If there is no collision of this electron, then this electron will come out with an energy of 0.5 electron volt. That 0.5 electron volt energy will be the kinetic energy of the electron, will be the maximum kinetic energy of the electron.
Yes, sir.
Okay, so work function is depend on the nature of the material. You can see here different metals like cesium, potassium, copper have different work function. Okay, so for cesium the work function is 1.9, potassium work function is 2.2, copper work function is 4.5. Now we will discuss the maximum kinetic energy, the concept of the maximum kinetic energy. Now it is very easy to explain. Suppose the work function of this metal surface phi is 2 electron volt.
Yes, sir.
And you are providing the energy of 8 electron volt. Okay, if to this electron you are providing the energy of 8 electron volt and work function is 2 electron volt. So when the electron will eject out, what will be the energy of electron? Okay, 2 electron volt energy will be expended in the to overcome the work function.
So it will be 6, right?
6 electron volt will be the maximum kinetic energy. Okay, so here if no collision is taking place, remember, if no collision is taking place, then we can say that the electron will come out with an energy of 6 electron volt. So 8 electron volt you are providing, 2 electron volt is expended to overcome the work function, and there is no collision, so no energy is wasted in the collision. Then here there will be 6 electron volt kinetic energy. Kinetic energy of electron will be 6 electron volt, and this will be the maximum kinetic energy. When there will be no collision means there will be the maximum kinetic energy. Okay, now if suppose the collisions are taking place, you are for this electron you are giving 8 electron volt and 2 electron volt is expended.
6, right?
Yeah, and but here what will happen? It have remaining energy 6 electron volt. Now some energy will be wasted in collision also. Now this electron is collided with some other electron, so some energy is expended in collision. So now the net energy of the ejected electron will be less than 6. You can see here 8 electron volt you are providing, 2 electron volt is expended to overcome the work function. Now 3 electron volt is wasted in collision. Now what is the total spend of energy? 5 electron volt. So remaining kinetic energy of the electron will be 3. Okay, see in this case 2 electron volt work function, 6 electron volt wasted in collision. So total 8 electron volt energy is wasted.
Yes, sir.
Means it's expended.
Yeah.
So here the kinetic energy of electron will be 0. Now, if this is a case, suppose 8 electron volt you are providing and 2 electron volt is the work function, but the electron expended the energy of 7 electron volt already in collision. Now how much electron volt energy left with electron? 1 electron volt. And what is the work function? 2 electron volt. Will the electron come out? No, there will be no ejection of electron. So now you can see the work function is 2, but you are providing 8 electron volt, and then in this case you can say there is no ejection of electron. Okay, why? Because the energy is wasted in collisions.
Yes, sir.
So this is what I have written. So now maximum kinetic energy of the electron, this is the maximum kinetic energy of the electron, can be given by E minus 5. Okay.
Yes, sir.
8 minus 2 is 6, so E minus 5. So we can write kinetic energy maximum of the ejected electron is equal to E minus 5. And what is E? Is the energy of the photon.
Yes, sir.
The formula
is the function.
Yeah, it will be given by HF minus 5.
Yeah, HC by lambda.
HC by lambda also you can write. And this is known as this equation is known as the Einstein photoelectric equation.
Yeah.
Einstein's photoelectric equation. Yeah. So all these equation I think we should know. This is one equation, na? This is not 3 equation. This is only one equation. Okay.
Yes,
maximum kinetic energy we can tell. We cannot tell the actual kinetic energy of the electron ejected, but we can tell the maximum kinetic energy because we don't know how much energy is expended in the collision. So what is this? This is Einstein photoelectric equation. Now here is one more point, I think. Okay. Okay, so now you can note down both these things. Both are very important concepts.
Second scroll down. Done, sir.
So write down this point also. If we supply energy greater than the work function, it is not necessary that electron is ejected out of the metal surface. Why? Because there can be the energy wasted in collision also. So
Yes,
write
sir.
down this point also.
Yes, sir. Done, sir.
Okay.
Second scroll up 1 minute.
Scroll up.
Yeah, just start. Okay.
So it is written that maximum kinetic energy of ejected electron.
Second scroll down.
Yeah. Understanding this thing,
Yes, sir.
these things.
Yes, sir.
Hmm.
Second scroll down.
Yeah.
Done, sir.
Okay. So like you have seen work function. What was the work function? The minimum amount of energy required to eject an electron from the surface. Now we will discuss the threshold frequency. Threshold frequency. So threshold frequency is minimum amount of frequency of radiation to eject
Yes.
an
To
electron.
eject an electron.
Very simple. Threshold frequency. We will see one graph also on threshold frequency. So threshold frequency is this. Is represented by F naught. We will represent threshold frequency with F naught, the minimum frequency of incident radiation which may cause photoelectric effect. Photoelectric effect means the ejection of electron from the metal surface.
Yes,
Now
sir.
we know that for the electron emission, for the electron to be emitted, we know energy supplied either greater than phi or equal to phi. Okay, phi is the work function. Now
Yes,
what
sir.
is E? E can be written as H into F, and this is greater than or equal to phi. From here you can find the frequency that will become greater than or equal to phi by H. Now finally you will have the minimum frequency. You can see here frequency either greater than phi or equal greater than phi by H or equal to phi by H. Now what will the minimum frequency? Minimum frequency will be phi by H.
Yes, sir.
It will be phi by H, and this minimum frequency is known as the threshold frequency. So you can say that F naught can be written as phi by H. F naught can be written as phi by H. So we have one formula of phi. Work function of a metal surface is given by H into threshold frequency.
See.
Yeah. Now, okay, we will use Einstein's photoelectric equation. Oh, what I'm doing? Just wait a minute. Okay. So what is the Einstein's photoelectric equation? Kinetic energy maximum is equal to E minus phi. E minus phi. So kinetic energy maximum, the value of E is given by H into F. The value of phi,
HF.
the value of phi we can put H into F
HFO.
naught. H
Yeah,
into
F.
F naught. Okay. Now there is a equation of a straight line, that is y is equal to mx plus c. If this is an equation of a straight line, na, then in this case now what is will be there? The graph will be between y and x, and this type of graph we will have. For this graph, the slope of this graph is represented by m, and that will be tan theta.
Yes, sir.
And this value will be the y-intercept, that is equal to c. If the graph is like this, y is equal to mx minus c. If the graph is like this, y is equal to mx minus c, then in that case, this is x, this will be y. In that case, the graph will be like this. So the slope of the graph will be again tan theta. If this angle is theta, slope of the graph will be tan theta, that is equal to m. Okay, and this value will be c in negative direction. Okay, so both the graph you should know. Okay, so if we will draw the graph now, this is this equation we have, y is equal to mx plus c, or talking about this equation, y is equal to mx minus c. So we have a graph between y and x. Okay, now here we will draw the graph between the maximum kinetic energy and frequency. So we can compare this with y is equal to mx minus c.
Yes,
Okay.
sir.
So the value of c we will have h into f naught. The value of the slope we will have, you can compare this. F is representing here x, so slope will be equal to h,
Yes,
and
sir.
y is the maximum kinetic energy. So you will have this type of graph between the kinetic energy maximum and the frequency of incident radiation. So frequency of photon, you can say, or frequency of incident radiation, f, and kinetic energy maximum of the electron, and this type of graph we have, and this value will be c, intercept, and that intercept is equal to minus h f naught, or h f naught, you can write h f
Yes,
naught.
sir.
The value is h into f naught. And what will be the slope of this graph? Theta. Slope of this graph is equal to tan theta, or m. What is the value of m? M is h. M is equal
H.
to h. Means the Planck's constant will be the slope of the graph. And this value of the graph will be the threshold frequency. Means after this frequency, there will be the ejection of electron. After this frequency, then only there will be the kinetic energy of electron. Otherwise, the
Yes,
maximum
sir.
kinetic energy is 0. So after a certain frequency, there will be the ejection of electron. There will be the photoelectric effect. Okay, note down. So main thing here, you have to understand what the graph is saying, means how to draw the graph.
Second scroll down. Second scroll down. Second scroll down. Second scroll down.
Hello, Harsh. What happened?
Sir, I got disconnected.
Hello,
So
Harsh, your voice is not coming. Hello, to listening me? Oh, okay. Hello, hello, Harsh.
sir, can you hear me?
Yeah, I can hear you. What happened? Why you left the meeting?
Sir, I got disconnected, sir.
Okay. So have you completed this?
Yeah, sir. Actually, my mic is not working. Can you just scroll down?
So this graph you have to understand y is equal to mx plus c, y is equal to mx minus c. Okay. Accordingly, you will draw the graph.
Done, sir.
Okay. Write on this graph. After this, we will discuss the like threshold of frequency is there. The minimum amount
of frequency to remove an electron from the metal.
Yeah.
Sir.
No,
Done.
not to remove, not to remove. Actually, you have to say like this: the
Eject.
minimum amount of energy, the minimum amount of frequency, so that there should be photoelectric effect. In this way, you can say,
Okay. Yeah.
or you can say the minimum frequency of radiation, so that there should be the ejection of electron from the metal surface. Okay,
Yes, sir. Done,
removing an
sir.
electron means, actually this is related with chemistry. You are removing an electron from the outermost shell of the
Yes, sir.
atom.
Done, sir.
Yeah. So now we'll discuss the. Now here, see the definition: the minimum frequency of incident radiation which may cause the photoelectric effect, known as the threshold frequency. Now, threshold wavelength, you will say the maximum or the longest wavelength of incident radiation which may cause the photoelectric effect. The longest wavelength, you will say. You can see the longest wavelength of the incident radiation which may cause the photoelectric effect. Okay, for the frequency, what you will say? The minimum frequency, or for the wavelength, what you will say? Because they are opposite. If you can say that for red light, choose the red light. Okay, for red light, the wavelength is maximum. In Vibgyor, the wavelength of the red light is maximum, but the frequency is minimum. So that is why if the frequency is the minimum, then wavelength will be maximum. That is why we are saying the longest wavelength of incident radiation which can cause photoelectric effect. Now, same phenomena, same process we will follow to calculate that. For electron emission, energy should be greater than or equal to the work function. Energy can be written as Sc by lambda, that should be greater than or equal to 5. Okay, from here, from this equation, you can find the lambda less than or equal to Sc by 5. If lambda is less than Sc by 5 or equal to Sc by 5, then maximum value of the lambda will be Sc by 5, and this maximum amount of lambda is known as lambda naught. Okay, and you can say Hc by 5 is equal to lambda naught, so 5 can be written as Hc by lambda naught. So there is one more formula now we have of lambda naught of 5 in terms of the lambda naught. What is lambda naught? Threshold wavelength. Phi is equal to Sc by lambda naught. Now we will apply maximum kinetic energy is equal to E minus phi, Einstein photoelectric equation. Now E can be written as Hc by lambda, phi can be written as Sc by lambda naught. Now we will draw the graph between the maximum kinetic energy and 1 by lambda. Again, this will be the equation of a straight line. Okay, so you can write it as kinetic energy maximum is equal to this is the graph between Hc and 1 by lambda, between lambda naught. Now you can say you have a graph of maximum kinetic energy and 1 by lambda.
Yes, sir.
It will be y is equal to mx minus c. Y is equal to mx minus c type graph you will have, means this type of graph you will have. Okay. There is a reason why the graph is like this, because see the equation. We are drawing the graph between the maximum kinetic energy and lambda of the radiation, 1 by lambda, not lambda. The graph is in between the maximum kinetic energy and 1 by lambda of the radiation. This
Yes,
value will
sir.
be 1 by lambda naught, and this intercept is a negative intercept. This is hc by lambda naught. You can see here hc by lambda naught. C.
Yes, sir.
So here we can draw this as with the dotted line. So after this 1 by lambda naught, there will be the photoelectric effect, or there will be the ejection of
Electrons.
Yeah.
Yes, sir.
Okay, write down.
So you can scroll down.
Yeah.
So you can scroll down.
Yeah. Done?
Yes, sir.
Okay. Now there is one more topic, very small. If we this is already we have completed. Before that, we should know this point. Point number 7. If we will increase the intensity, or if we will
Of
change the
radiation,
intensity, then
the
number of
photons
will
increases, but not the energy of photons.
Yeah, but not the energy of a single
Photons.
photon.
Yes.
This is what you can say maximum kinetic energy can be written like this, E minus 5.
Yes.
So basically maximum kinetic energy is depending upon the energy of a photon minus work function.
Yes.
Energy of a photon minus work function.
function.
And if you, it means if you will change the energy of photon, then the kinetic energy maximum will change, or if you will
Yes.
change the metal or work function of the metal, then the kinetic energy of the maximum will change. But if you will increase the intensity of radiation, will there be any change in energy of electron? No. There will be no change in the work function, because
No.
work function
No.
is depending upon the material. Okay, work function is depending upon the material. So if you will increase the intensity, means from here to here, if you will increase the increase the intensity, then kinetic energy maximum will remain same. So you can see the graph. You are increasing the intensity, kinetic
Yes.
energy will remain same. So you can add this point here, and you should now
Yes,
write
sir.
down. This is the last point. Okay, please write down fast.
Sir, I wrote that point.
You have written this also, this one. This one you have written, but here
No, sir, I've written this one.
yeah, you have to write this here also, because here there is a requirement of that point.
Okay, sir. Okay, sir.
You should know, whenever you are increasing the intensity, number of photons will increase, but energy of each photon will remain same.
Photons
Because
increase,
energy of
but not
photon is
the
not depending upon the intensity, it is depending upon either frequency or either on wavelength.
intensity
Yeah.
or length. Yes, sir.